Continuing with problem number 16. So for this graph, what we want to do is we want to draw the proper velocity versus time graph. And really this involves calculating some slopes. So I'm going to go ahead and do that right now. And remember, we're going out to 15 seconds. And we're starting at 0. So here, it looks like over a period of 4 seconds, my position goes from 2 to 6. So if I do the rise over run in that case, let me make absolutely sure I got that right. Now my position goes from 2 all the way up to 8. So if I want to get the velocity for the first part here, from 0 to 4 seconds, and then 4 to 9, 9 to 15, from 0 to 4 seconds, I need to take 8 minus 2 divided by 4 minus 0, and that's going to give me 3 halves. And I can just kind of write here 1, 2, 3. My velocity right here is just going to be 3 halves all the way out to 4, like that. And I would label this as 3 halves. Okay. Now, what happens from 4 seconds to 9 seconds is that my speed goes from, or my position goes from 8 to 6. So that means to get this second part here, that's going to be here 6 minus 8 over 9 minus 4, and that gives me negative 2/5. So I need to actually draw that here. So 1, 2, and negative 2/5 is going to be from 4 to 9, not quite at 0. Whoops. It's going to be right here, like that. And then from here to here, from 9 to 15 seconds, I'm not moving, I'm at rest. So the way I actually label that from 9 to 15 is a nice flat line. Now, for problem number 17, we're going to go ahead and solve it. So a police car sitting at a stop sign notices a speeder 300 meters ahead, moving at 25 meters per second, and the car is already moving at 30 meters per second to catch the speeder. So here we go. What's happening is I have the police car here, the speeder is at 300 meters, the police car's here, the speeder's here, and I'm going to write down equations for both. So the police car's position as a function of time is going to be 30t plus its initial position of 0. The equation for the speeder is going to be 25t, and its initial position is 300. So using these two facts, we're going to go ahead and we're going to determine the position and the time at which the cop car catches the speeder. So we're going to do that by setting these two things equal. By setting them equal, we're saying they meet at the same point. So the police car position is the speeder position when they meet up. So that means 30t plus 30t plus 0 equals 25t plus 300. And so I'm going to plug in here. I'm actually going to just rearrange this equation. I'll get 5t equals 300, and t is going to be 60 seconds. Now what I'm going to do is, this is the time. What I'm going to do is I'm going to go ahead and plug that back into here. And when I do that, I will get x of the police car equals 30 times 60, which is 1,800 meters. And so that solves the first exam. In the next page of videos, I will actually go ahead and take a look at exam number 2.